Hi, I'm Susan Haddock, a commercial horticulture integrated pest management agent from the University of Florida Institute of Food and Agricultural Sciences Extension at Hillsborough County, Florida. I primarily work with professionals who design, install, and maintain urban landscapes. During my work with these professionals, I've gained a bit of an insight into the challenges involved in maintaining urban landscapes. I hope that you're able to gain some additional insight from this presentation too. The objectives are to provide an overview of the urban development process, address the challenges of urban landscape maintenance, while keeping in mind habitat preservation for wildlife and human use. During the urban development process, there are a lot of forces at work. Policymakers, environmental consultants, developers, landowners, and the public all need to communicate successfully. During that process, they should be considering low-impact development, conservation subdivisions, smart growth, biodiversity conservation, and sustainability. In general, the urban development process involves three phases: design, construction, and post-construction management. The design phase involves locating the development and the roads in and around the development, the type of homes that will be included in the development, and the amenities that may be in or around the development, and how much open space will be included. The construction process involves a lot of different entities: developers, site managers, civil engineers, contractors, subcontractors, and landscaping architects. Post-construction management may involve community development districts, homeowner associations, landscape maintenance companies, and individual homeowner management. During these three urban development processes, there is what I consider to be a sphere of habitat and biodiversity. During that initial design phase, when the location is being selected, that sphere is very great. It's untouched land in most cases. When you get into the construction phase, it shrinks that habitat and biodiversity a little bit more. And then when you get into that built-out environment during post-construction management, that sphere of habitat and biodiversity is even smaller. For reference, habitat means the place or environment where a plant or animal naturally or normally lives and grows, and that includes humans. Biodiversity is the variety of life, the number of habitats and species within a local area or region. The urban development process can have an effect on biodiversity. It can affect ecosystem diversity, which is the variation of aquatic and terrestrial ecosystems and how they interrelate to each other, species diversity, which is the number of different plants and animals in a given area, and the genetic diversity, which is the genetic makeup of a plant or animal within the locality in which it is found. When we isolate species due to urban development, we can reduce the genetic diversity of plants and animals. Including wildlife corridors can preserve habitat and biodiversity, as well as provide green space for human enjoyment and relaxation. Consider this green rectangle as a clean slate prior to any development. The brown represents a development going in. There's still a lot of green space and connectivity to the surrounding habitat. Here's another development, a little bit less green space, but still has a lot of connectivity to the habitat. And a third development, still providing that connectivity. Here's a fourth development. It has an isolated pocket of green space. This is great for human enjoyment and relaxation, however, could result in reduced genetic biodiversity due to its isolated pocket in the center. Now close your eyes and think about these developments, including utilities, roads, schools, restaurants, strip malls, and how that could impact the habitat and diversity of the area. So where does University of Florida Extension come in? Extension faculty serve as consultants. Master gardeners serve as educators and problem solvers for residents. But typically, we are involved after the design process is complete and when those landscape challenges become evident. Ideally, our goal is to have interaction with policymakers, developers, designers, landscape installers, and homeowners during the development process. I mentioned earlier that the urban development process involves a lot of different entities: policymakers, developers, contractors, landscape architects, environmental consultants, and many more. It's very typical for us to assume that everything possible has been done during the development process to ensure a successful and sustainable landscape. If that assumption is true, then standard maintenance practices is all that is needed to maintain a landscape, right? Well, maybe that assumption is wrong. The reality is that in most, if not all urban landscapes, compromises have been made between budgets, deadlines, regulations, design, and quality. During the development process, inaccurate assumptions can be made, mistakes can happen, communication problems occur, and compromises are made. These issues can accumulate. Often, landscape problems are not readily apparent, but eventually, months and years later, the landscape will reflect the problems. At that time, it becomes even more difficult to maintain the landscape and to restore habitat and biodiversity. Potential problems that can occur during the development process that impact the landscape include tight budgets and tight deadlines that can result in shortcuts, construction activities, poor fill dirt, soil problems including no topsoil, pockets of clay, compacted fill dirt, or a combination of all of these, poor landscape design, poor irrigation design, poor plant quality, and poor installation practices. Post-construction, others, including property managers, maintenance contractors, and homeowners, may not be aware of the problems that contribute to landscape maintenance issues. So I ask you, can the urban development process set up landscapes for failure? Think about things like why it might be difficult to maintain landscapes using standard maintenance practices, why landscapes may require large inputs of water, fertilizer, and pesticides. Also think about social norms and public expectations. Have these changed? Is there a perception that we should have perfect-looking landscapes? Is there a perception that we should be intolerant of any imperfection, such as a few weeds? If any one of these landscape components, soil, design, plant quality, or water and maintenance practices, is not correct, then the landscape may not perform well and may fail. Let's first take a look at soil basics, as landscape appearance often indicates a deeper problem. All soil has a soil profile, and in general terms, the topsoil is where plants root and grow. It usually contains organic material. Plants need topsoil to grow well. The subsoil lies below the topsoil and contains little organic material and little oxygen necessary for plant growth. The bedrock is the solid rock underlying the subsoil. An ideal soil should contain about 45% minerals and 5% organic matter. It should also have about 25% space for air and 25% space for water. Soils in a natural setting are formed over a long period of time, provide medium for plant growth, provide a variety of physical and chemical functions, and act as environmental filters. The photos on the right show a variety of different soil profiles. In Florida, there are 7 different soil orders, which is a USDA system of soil taxonomy. They're very diverse and include sands, mucks, marl, and rock plowed. They represent contrasting media for plant growth and support different types of plants. There are marked differences between and among even sandy soils. Soil pH is a measure of the acidity or basicity of a soil and is an indication as to whether or not that soil is ideal for plant growth. If the soil is too acidic or too alkaline, the plant may show symptoms of nutrient deficiencies or toxicities. Once the soil pH is known, you can determine which plants may perform well in that situation. You can also determine which soil additives might be necessary to help plants perform better. But some plants just don't do well in a very high or a very low pH. and there's no management practice that you could put in place to make them perform well. Most of the construction in Florida is slab-on-grade construction. This means that the elevation of the property is brought up to a level predicted not to flood, and then the homes are built on a concrete pad. The soil to increase the elevation is excavated to make stormwater ponds from that site and also brought in from fill pits. In many developments, stormwater ponds are viewed and marketed as lakefront property. Stormwater ponds then become multi-purpose with competing functions, stormwater drainage and aesthetics for homeowners. Those soils excavated from stormwater ponds and fill pits may have elevated phosphorus levels. Slab-on-grade construction building codes require a stable foundation for construction. A stable foundation means compacted fill dirt, not soil. Fill dirt is typically excavated from fill pits well below the level at which plants grow. The pictures below show the wide range of soil types that are brought in to elevate properties. Also, note how the native soil pH and fill dirt pH differ. Fill soils used in urban construction can cause a number of landscape problems. Physical problems include layering, compaction, poor structure, and drainage issues. Chemical problems include low organic matter or fertility, low or high pH, and high salinity. Biological problems include low microbial activity and plant pest pressures. These slides show another common problem in urban construction. The white areas on the slide are where concrete was mixed for building the house with the concrete block. These areas are typically not cleaned up well and produce areas in the landscape that could not perform well after they're installed. These two photographs show the amount of debris that is around a house during construction. In many cases, some of this debris is raked up. However, it's not cleaned thoroughly from the surface prior to plant installation. These photographs show three different issues. The photo on the left shows poor drainage. The poor drainage problem has not been corrected, yet the irrigation has already been installed and the landscape will go in next. The slide at the top right shows three different fill dirts being used. This can have an effect on how the plant material planted in that dirt performs. In many cases, it may be turf grass that doesn't perform as expected. The bottom right slide shows where the concrete mixing occurred. Again, this can affect the pH of the soil and the performance of the plant material. When you encounter problems in a landscape, think about the underlying soil and if that could be causing the problem. Sometimes a quick check with a soil probe or a soil profile in a number of areas can tell you the quality and the layers of your soil profile. And don't forget about checking the pH. Checking the underlying soil can also give you an indication of whether or not the soil is compacted. Compacted fill limits the growth of plants. In some cases, the soil is very compacted and the sod is laid directly on that compacted fill and the plants installed directly in the compacted fill, without any topsoil or even sand for plants and sod to root into. Think about this. If you place sod directly on top of and plants directly in a bedrock type soil, that's similar to installing in cement. There is no loose soil in which roots can grow. It also can limit the root to shoot ratio. Normal plant growth requires root to shoot ratio. There needs to be enough canopy to absorb sunlight and photosynthesize to support the roots, and there needs to be enough roots to uptake water and nutrients to support the canopy. But when we have poor quality fill dirt, both the canopy and the roots are limited. Planting in compacted fill dirt has the same effect as leaving the plant in a pot. If the soil surrounding the root ball is so compacted, the roots will just circle around in that area and not have good lateral root growth. Plants can look great on installation and for several years, even when installed in compacted or poor quality fill dirt. However, several years down the road, you'll begin to see the impact of that poor quality fill dirt. Trees tend to be a good indicator. They show symptoms by showing tip dieback and excessive lichen growth. Both of these are indicators of the tree being stressed. This photo shows the root ball of a tree removed 5 years after it was originally installed. Note that there is very little root growth outside of the original root ball of the tree. This is the result of compacted and poor quality fill dirt. Also note on the surface of the soil around the trunk the white strapping. The strapping is used to support the basket when the tree is installed. That should always be removed, as it will girdle the tree as the tree matures. These two photographs show how compacted and poor quality fill dirt can affect both turfgrass and woody ornamentals several years after installation. Without taking a look at the underlying soil, one might think that this is a pest or disease problem. Now let's take a look at landscape design, as landscape appearance often indicates a design problem. Landscape design should incorporate the 9 principles of Florida-friendly landscaping. However, in the urban development process, we frequently see cookie-cutter designs and the use of the same 10 plants. In many cases, site and soil conditions are not considered. Cookie-cutter designs don't include assessing whether or not the site is shady or sunny, how close to the coast the site happens to be, or any number of other factors that should be considered. In new development, plants are installed very close together to give a mature look. The actual size of the plant as it matures is not considered. This creates problems down the road as there is little airflow and plants are crowded. There is also the problem with availability versus demand plants. Nurseries tend to grow what developers want, and developers think they want what the nurseries are growing. Unfortunately, this is not Florida-friendly landscaping. Landscape design may be contracted to a national firm with little knowledge of local plant palette, soil types, and weather conditions. A 1-hour drive in any direction in Florida results in changes in which plants will grow locally. Residents new to Florida tend to want a very tropical look, so we tend to continue to push tropical plants further and further north in Florida, where they may not perform very well. The designer may be working off a blueprint from hundreds or even 1,000 miles away. In some cases, the design is due before the actual site even exists. Without visiting the site, important details can be missed. Sun, shade, wind, drainage, habitat, and even local laws and ordinance might be overlooked. Landscape design should include planting the right plant in the right place. Building development codes often require tree canopy to be replaced during the development process. However, are street and parking lot island trees sound design to replace the tree canopy? As trees mature, the roots can cause a lot of damage to parking lots and sidewalks. This damage can also present a hazard. You know it's poor design when it has to be pruned to make it fit. These palms are planted too close to the building to accommodate the mature size of the canopy. Constant pruning is expensive and can promote pest and disease problems. The palms are planted only about 2 feet from the building. You know it's poor design when it has to be tied to make it fit. This Bismarck palm is planted too close to the building. Consider that it will have a trunk diameter of 15 to 18 inches and a canopy spread of 12 to 16 feet. This picture shows an oak tree planted about 2 or 3 feet from a building. Oak trees can have enormous trunks and a canopy spread of 60 to 120 feet on maturity. Oak trees should not be planted anywhere near buildings. Landscape design should consider turfgrass placement and whether or not that turfgrass should be purposeful. Healthy turfgrass has a dense root system, reduces runoff, supports bioremediation, prevents erosion, regulates temperature, sequesters carbon, promotes safety, and replenishes air. Even shade-tolerant varieties of St. Augustine require 5 to 6 hours of full sun per day. The turf between these buildings gets very little sun and will thin and become weedy over time. It's an easy mistake to make if you're working from a blueprint. This turf grass may be purposeful. It provides a walking path away from the street. But seriously, who would want to maintain this strip of grass between two rows of woody ornamentals? This photo shows another example of a live oak tree planted too close to a building. Should that turf grass area be mowed or string trimmed? What's going to happen to the turf grass as the tree grows? Remember how much sunlight turf grass needs? A minimum of 5 to 6 hours per day. As that tree grows, the area will become shaded and the turf will thin and become weedy. Wrong plants, wrong place. Now let's consider the reality of mature landscapes. Landscape maintenance works well when the property managers, maintenance contractors, and residents operate as a team and understand each other's goals and limitations. The following slides are going to show some of the landscape problems that can be encountered with mature landscapes. Many landscape plants are installed in areas where on maturity they will be too large. As a result, they are constantly pruned, creating that leggy look and witch's brooming. Constant pruning also prevents the plant from blooming and we lose that beautiful look. Look at this butterfly bush planted in an inappropriate place and the picture on the bottom showing it in full bloom. The Indian hawthorns in the top photograph are constantly pruned to maintain a height of 1.5 to 2 feet. Indian hawthorns naturally have a mature height of 3 to 7 feet and a spread of 6 to 10 feet. The Indian hawthorns on the top are having some dieback issues. Constant pruning can promote disease problems which promote dieback. Firebush is a beautiful flowering shrub that produces nectar for butterflies and hummingbird. The shrubs in the top picture are being maintained at a height of 2 to 3 feet with a spread of about 3 feet. The natural habit, as shown in the lower photo, is 6 to 12 feet high with a spread of 5 to 8 feet. The shrubs in the top picture are pruned so frequently that they rarely have blooms. Bottlebrush is actually a tree, but I've seen it installed as a hedge a lot recently, as shown in the picture in the top. It's being maintained at a height of 4 feet and a spread of about 3 feet. It's very crowded and the plant density is thinning. It is hedged, so we rarely see the flowers. The natural habitat of a bottlebrush is 10 to 20 or even higher in feet and a spread of 10 to 15 feet. Best management practices for shrubs include not forcing a shrub species to fit into a space that is too small for its natural growth pattern or vigor, and maintaining the proper size of shrubs using appropriate thinning and heading cuts as needed to manage shrub growth, size, and health. The Florida-Friendly Landscaping Guide to Plant Selection and Landscape Design is available through some extension offices and complimentary of the Southwest Florida Water Management District. This guide provides a lot of good information on all types of plants, including shrubs, trees, ornamental grasses, annuals, and perennials. The information includes thumbnail pictures and information regarding where the plant will grow best, and of course that important information regarding mature height and spread. Ornamental grasses can provide a lot of interest and texture to landscapes. Since many grasses keep their showy flower stalks through the winter, wait to prune until late winter or early spring, just prior to new shoot growth. Some grasses, such as muley grass, should never be pruned. Just run a rake through them to remove dead blades. In the photo on the right, the grasses, which should have a spread of 4 to 6 feet when mature, have been planted very close together in a 6-foot ring around a tree. Unfortunately, they are constantly pruned so that they will fit in that diameter circle. The photo on the left shows how beautiful this grass can be. These plants are still too close together, but luckily these photos show how beautiful showy flower stalks can be as compared to how they look when they're inappropriately pruned too frequently. Street trees can become very problematic as they mature. In this photograph on the left, there are 2 live oak trees planted fairly close together. Remember that 60 to 120 foot spread I mentioned? They will be growing into each other and over the house very soon. The trees are also placed very close to multiple utilities: a street light, a storm drain, and a water meter box. One of the tree's root system is already growing into the water box. This landscape has 5 trees planted very close to each other. The live oak placed between the storm drain and the water meter box should never have been located there and should be removed now. Now let's take a look at plant quality, as poor landscape appearance may indicate a plant problem. A grower's job is to produce uniform, high-quality plants as quickly as possible in an ideal environment, where soil or planting medium is high quality and irrigation and nutrients have been provided as needed. When plants are purchased from a nursery or a garden center, they may be a little chemically dependent and pumped. What I mean by this is during the growing process, they may have been treated with preventative pesticides and, of course, optimal nutrients to produce those high-quality plants quickly and pest-free. Bahia grass was initially installed on this sloped landscape. The slope made it difficult to maintain, and it was over-irrigated. As a result, the turf grass became weak and thin and weedy. It will never reach its potential. Do we set up healthy plants for failure in poor fill dirt, compacted soil, poor irrigation, and poor design situations? Plant roots should be inspected prior to installation. They should be a nice creamy color and not waterlogged. Circling roots should be cut prior to installation to disrupt that pattern of circling growth. If that circling growth pattern is not disrupted, it will result in continued circling root growth as shown in the lower photograph. Circling roots can girdle a tree, prevent good stable lateral root growth which supports the top of the tree, and cause instability in the landscape by having a top-heavy tree. Both installation timing and plant quality affect the health of plants. Some plants, such as trees and shrubs, can be installed while dormant or during cooler weather. Other plants, such as turf grass, tend to establish better when installed during the growing season. This way, they can establish a good, strong root system. Turf grass that is installed while it is dormant may just sit on top of the ground for quite some time prior to establishing a root system when temperatures warm up. Now let's take a look at water in landscapes, as landscape appearance often indicates a wetness problem. In Florida, we have water quantity issues where our water supply needs already exceed capacity in some areas. I know this may be hard to believe since we are surrounded by water with stormwater ponds, lakes, rivers, streams, the Gulf of Mexico, and we have that rainy season from June through September that produces 60 or more inches of rain on average each year. However, we do have some problems with water accessibility, competition between urban agricultural and recreational needs, the costs of mitigating water quality issues, and considerations on whether or not our landscape use of water is purposeful. The population of Florida is predicted to continue to increase. Currently, we have about 1,000 people a day net moving into Florida. High estimates are that we will have about 26 million people by 2030. This is an estimate provided by the Florida Chamber of Commerce. The Water 2070 report, which was issued in November of 2016, reports that water demand with an additional 15 million people by 2070 would reach about 9 billion gallons per day. That's an increase of 54% over water use in 2010. Under the alternative development scenarios with more compact development and modest conservation, water use would still increase by 30% to 6.9 billion gallons of water used every day. I mentioned alternative development scenarios. The photograph on the top shows traditional development. The photograph on the bottom shows an alternative development scenario where there is a much less proportion of the development devoted to landscaping. The urban development process changes the water budget. It reduces canopy vegetation and increases impervious surfaces. This results in reduced groundwater recharge by infiltration, reduced evapotranspiration, and increased runoff. On the right, you can see how these changes occur with increased urban development density. Irrigation is important to consider, as up to 50% of potable water is used for landscape irrigation in Florida. There are some common irrigation problems: turf and shrubs on the same zone, lack of head-to-head coverage, pressure problems, mixed heads on the same zone, which means there are unmatched precipitation rates, the system not being calibrated for precipitation rate and uniformity, and watering too much during the dormant season of November through March. The photo on the left shows a uniformity problem, creating a dry spot. The center photo shows an irrigation head that was probably placed when this tree was very small or not installed. The tree is now blocking the irrigation for quite a portion of the landscape. The photo on the right shows uneven irrigation coming out of the spray head and irrigation during rain. The photo on the top left shows an overpressurized system. The photo on the top right shows a poorly placed head, and the photo on the bottom shows mismatched heads. The photo on the top right shows poor placement of irrigation heads as the pond is being watered. The photo on the top right shows better placement of irrigation heads so that they are pointing away from the pond. The photo in the center bottom shows better placement of irrigation heads, but heads that are poorly managed as one is still turning too far and watering the pond. So what is the purpose of irrigation in urban landscapes? It is designed to provide supplemental water to plants to meet transpiration needs when there's not enough rain. It's intended to be used efficiently and with conscientious awareness of water conservation and quality issues. Irrigation should take into account precipitation from rainfall, evaporation from soil, and transpiration from plants. Precipitation is the condensation of atmospheric water through rain, drizzle, snow, sleet, or hail. Infiltration is the process or rate at which soil is able to absorb rainfall or irrigation. Evapotranspiration takes into account evaporation and transpiration. Evaporation is water lost to the atmosphere from the ground surface, groundwater, and from plant leaves. Transpiration is water evaporating from leaf surfaces. When working with or providing information about irrigation, there are a number of terms that you should be familiar with. The valve receives the signal from the irrigation controller box, which prompts the valve to open and allow water to flow. Irrigation station. In most cases, one station controls one valve, which in turn controls one zone, or certain area of a property. The irrigation zone is the actual area that is receiving the irrigation. Hydrozones refer to grouping of plants with similar water needs in the same zone. An irrigation system map is a pen-to-paper map drawing that outlines the location of valves, lines, heads, zones, and types of plants and foliage. Many urban residents are unfamiliar with their irrigation controller. The norm seems to be a set-it-and-forget-it mentality, which results in frequent overwatering of landscape plants. We should embrace the irrigation controller. It will allow us to create an irrigation schedule that meets our plants' needs. This conserves water when programmed and used correctly. It preserves water quality when programmed and used correctly. It keeps plants healthy when programmed and used correctly. It saves you time and money. Do you have too much time on your hands? If you do, come see me. I can put you to work. It also saves potable water and aquifer water resources, saves electricity, and it reduces fertilizer and pesticide applications and the need for plant replacement. There are typical controller features that we should be familiar with. One is the current date and time. This allows us to set the year, month, day, and time. Another is the program start time. This is where we specify a time of day to start irrigation. Southwest Florida Water Management allows irrigation between 6 p.m. and 8 a.m. The best time to irrigate is early morning. For example, 5 a.m. if you're able to get through all of your zones before 8 a.m. There will also be multiple programs, A, B, C, on many controllers, where you can set multiple start times. For usual urban irrigation purposes, only one program should be set with a start time. The others should have no time, unless there are specific circumstances that warrant multiple start times. Station run time lets us specify how long to run each station or zone. That should be based on the water needs of the plant group. The days to water specifies what days of the week to water. This allows you to be compliant with watering restrictions in your municipality. It also allows you to skip a week. Set the dial to run to enable automatic operation of the program. This is the set it and forget it setting. Please don't set it here unless you know there is a properly functioning rain shutoff device. The system off setting turns off the program schedule. The program schedule is saved. This can be used to cancel watering in progress. The system can also be left in the system off station during the rainy season and only run when the landscape looks like it needs water. The manual single station setting manually runs a single valve or zone in a program. On some irrigation controllers, it will manually run the entire program. It can be utilized to spot check the system and perform repairs. The seasonal adjustment setting will make across-the-board adjustments to watering programs based on a percentage basis. During extremely dry, hot weather, it can be set above 100%. An example is if your zone is set to water for 30 minutes and you change it to 120%, it will now water for 36 minutes automatically without making any other adjustments on the controller. Once the daylight hours shorten and nighttime temperatures dip into the 50s or lower, plant growth slows and therefore less evapotranspiration occurs, and you can set this below 100% if you don't want to make any other controller adjustments. As an example, again, if you are watering a zone for 30 minutes, if you set it on 50%, it will then water that zone for 15 minutes. So this is great because the soil is not drying out as deeply and you can save water. If the rain sensor bypass is set in the bypass position, it automatically disables the rain shutoff device. It should not be set in the bypass position. It should be set in the active position, and homeowners should make sure that their rain shutoff devices are properly working. The typical homeowner rain shutoff device shown on the photos has cork in it. As the cork swells, it gets heavier and puts weight down, which inactivates the irrigation system. As they dry out, it gets lighter and lifts, and the electrical connection is now enabled that allows the irrigation system to come on. These cork discs dry out over time and can crack. They should be inspected and perhaps replaced annually, or the entire rain sensor can be replaced with a new rain sensor or with better technology. Here's a rain sensor bypass fact. Florida Statute 373.62 from 2010 says the following: any person who operates an automatic landscape irrigation system shall properly install, maintain, and operate technology that inhibits or interrupts operation of the system during periods of sufficient moisture. This is a Florida statute. All automatic landscape irrigation systems require rain sensors or other shutoff devices such as a soil moisture sensor irrigation controller. An example of newer rain shutoff technology includes smart irrigation technology such as the solar sink. This device calculates evapotranspiration. It measures sunlight and temperature and uses evapotranspiration to determine the correct seasonal adjustment percentage value. This is a great water saver. Another example of smart irrigation technology is the soil moisture sensor. The soil moisture sensor takes a reading of the amount of water in the soil. The controller uses that information to open or close the switch. If the soil water content is below the threshold established by the user, the controller will close the switch, allowing power from the timer to reach the irrigation valve and trigger the irrigation to come on. After the irrigation controller is set correctly, you're not done yet. The irrigation system would need to be checked for uniformity and rate of precipitation. Uniformity means that the irrigation heads have correct head-to-head coverage and that you're not creating dry or wet spots due to uneven irrigation. Rate of precipitation means that you're applying the correct amount of irrigation for the plants in a particular zone. All irrigation systems can periodically benefit from an irrigation audit. This is a procedure to collect and provide information about the overall condition of the system, the uniformity of application, and the rate of precipitation. It's usually performed on overhead irrigation systems, although there are methods available to test drip irrigation. Formal audits are conducted by independent, certified landscape irrigation auditors. An irrigation audit involves several steps. The pre-irrigation inspection verifies that the irrigation system is in optimal working condition, identifies operation defects, and assures that corrections have been made. Calibration is performed most commonly by a catch-can method. It checks uniformity, how evenly the irrigation distributes water over the landscape, and the precipitation rate, which determines how long to run the system to deliver that 0.75 of water per irrigation event. We're almost done. Let's take a look at maintenance, as landscape appearance often indicates a hands-on problem. Post-construction management is landscape maintenance. This includes mowing, edging and trimming, fertilization, pest control, turf grass aeration, verticutting and top dressing, ornamental shrub and small tree care, large tree care, redesign and installation, and corrective actions such as drainage improvement or correcting nutrient deficiencies. All of the things we've already discussed can impact landscape maintenance. However, landscape maintenance practices in and of themselves can be problematic. I spoke about trees earlier and about how improper installation practices and poor quality can impact tree health. These photos show one of the most common things I see in landscapes: trees being planted too deep and straps left that will eventually girdle the tree. On the right-hand side, this shows strapping that was left that is starting to girdle the tree already. These photographs show trees with circling roots. If the trees are younger, like the one in the top left, there are some procedures of cutting the roots that can be done to promote lateral tree root growth. However, once the tree becomes girdled or the roots become very large, this is difficult to correct. These photos show trees with healthy, good lateral root growth. In the photo on the bottom left, although the tree is planted close to a sidewalk, it still has good lateral root growth. The photo on the bottom right is planted next to some asphalt, and although that root has taken a turn, it is well away from the tree, and the rest of the tree has good lateral root growth. This slide shows crepe myrtle. Of course, we all know this is a crepe myrtle that has been drastically pruned improperly. Crepe myrtles should be pruned so that no branch is removed that is any larger than the size of your finger. Of course, it's perfectly appropriate to remove spent blossoms. In many cases, crepe myrtles are drastically pruned because they're too large for the site in which they were installed. In this case, the canopy can be lowered by utilizing proper pollarding techniques. This is where the branches are pruned back to exactly the same spot every single year. It produces a hardened off node that looks a bit like a fist. Although many of us think that's an inappropriate look, it is the only appropriate way to prune a crepe myrtle that may be in a spot that's a little too small for the mature size of the tree. Ideally, shrubs should not be sheared or hedged. Shearing or hedging off the ends of branches promotes legginess, the witch's broom effect, and little to no interior or lower growth. Commercial companies frequently use gas-powered shears with up to a 5-foot cutting bar. This makes the job quick and easy. However, it still produces that little to no interior or lower growth and the witch's broom effect over time. My colleague in Pasco County, Jim Mull, refers to this as the Edward Scissorhands technique. Many shrubs are short-lived when constantly pruned hard. This is because pruning creates a wound every time a cut is made. Wounds provide an entrance area for disease and pest issues. If a formal hedge look is desired, it's much better to use a smaller leaf shrub species. These slides show that witch's brooming effect. This haircut pruning encourages new growth only at the top. When the hedge is kept at the same height, it often results in dieback of the woody stems. Shearing should be performed only when a formal hedge is desired. If hedges are going to be sheared, they should be sheared to keep the top of the hedge narrower than the base to allow sunlight to reach the lower branches so that the lower branches aren't shaded and die out. The best time to shear is when new growth is complete. There are best management practices regarding palm pruning. The extent to which a palm is pruned affects its vigor. Overpruning induces nutritional deficiencies. Overpruning also reduces cold hardiness and can transmit diseases. Some pruning can reduce vermin, such as the chances of a rat or possum living in your palm tree. All of these photos show healthy, full-headed palms. All of these photos show overpruned palms. Virtually all palms in the state of Florida are deficient in potassium. Potassium deficiency causes premature leaf senescence. Therefore, potassium-deficient palms are unable to support a full canopy of leaves. Potassium is a mobile nutrient. In a palm tree, it will move from the lower or older fronds to the newer fronds to support that growth. As a result, the lower fronds may look yellowed or even start to necrose or turn brown. Once they are fully brown or necrotic, they will fall and drop off the canopy eventually. So most palms in Florida only have half their normal number of fronds prior to pruning. The best practices for pruning palms is to only trim. Remove only completely dead fronds. It's best to leave unattractive, partially dead fronds due to the mobility of potassium. As I said, those old fronds provide a potassium source for the new fronds. It's fine to remove flower and fruit stalks, or badly damaged fronds, but we should never prune above 9 to 3 p.m. A full rounded head on a palm provides more insulation and wind deflection, protecting the terminal bud from wind and cold damage. This is why it's so important not to do that hurricane cut. The hurricane cut actually exposes the bud of the palm and during high winds can cause damage and death to the palm. Older leaves, even if unsightly, provide that nutrient source for new leaves. Keep in mind that not all palms need pruning. Palms with crown shafts should never be pruned if properly fertilized. Crown shafts is the region of smooth, usually green, tightly clasping leaf bases at the top of the gray trunk. A healthy old leaf will go from completely green in one day to completely orange-brown the second day and completely brown the third day when it should fall off by itself. Pruning tools can transmit diseases. This is another reason to only prune completely dead fronds. Tools can be cleaned by soaking in a 25% bleach or pine oil cleaner or soaking in 50% alcohol. 5 to 10 minutes between palms. For shrubs, between hedgerows, groupings, areas, and or neighborhoods. Having 2 sets of pruning tools will save time. One can soak while the other is being used. Finally, I'm going to speak a little bit about stormwater pond maintenance. When a stormwater pond is newly constructed, it has a gently sloping bank and the culvert is intact with no erosion. There is a connection between urban best management practices and natural and aquatic areas. In a natural system, erosion in plant material will eventually change a water body. The diagram below shows how a natural area can fill in with erosion and sediment over time to create an upland. The diagram on the right shows how a water body can also be filled in with erosion and plant material over time to fill in a water body. The same can happen to a stormwater pond. Ideally, we don't want this to happen to a stormwater pond because it will reduce the water holding capacity over time. So proper best management practice are imperative to keep stormwater ponds functioning correctly. These photos show a stormwater pond at 7 to 10 years post-construction. The water level is lower than the high mark, so we can see some of the damage caused by poor management practices. The culvert has moderate erosion, and the sloped bank now has a ledge. This makes maintenance challenging. The culvert erosion and ledge on the bank is caused by soil erosion. Soil erosion is created by an unstable bank. When there is not enough root material from the plants growing there to stabilize the bank, erosion will occur. Sometimes herbicides are also used to reduce the amount of grass growing along the bank of a stormwater pond. Wave action can also cause erosion. A best management practice is to never mow or weed whack to the very edge of a pond. Ideally, there should be some plant material growing at the edge of a pond to create that root to shoot ratio to stabilize the soil. These slides show a stormwater pond at greater than 10 years post-construction. Again, we can see the result of poor management practices. The bank has a much higher ledge, the culvert has severe erosion, and maintenance is very challenging and even dangerous. Take a moment to think about the amount of soil that has eroded away from that bank. Where did that soil go? It's now in the bottom of the pond. Soil buildup due to erosion of the bank and landscape debris that may get washed into a stormwater pond will over time reduce the stormwater holding capacity of a pond. This photo also shows a stormwater pond greater than 10 years post-construction. It has severe erosion, which is unstable. Wind and waves now undercut the bank and have led to a bank collapse. Maintenance is extremely challenging and dangerous, and the function of the pond is degraded. This type of situation is very expensive to repair and restore. To dredge the pond of the material that has eroded to the bottom and repair the bank can run in the range anywhere between $250,000 and over $1 million. Most homeowners, as residents in HOAs, don't realize that these costs are an assessment that are evenly assessed across all homeowners within a community. Properly maintaining a stormwater pond includes establishing a border of low-maintenance plants between the turf grass and the shoreline and keeping a 10-foot maintenance-free zone around the pond where there is no mowing or application of fertilizers or pesticides. The photographs below, from left to right, show an impaired pond being transformed into a fully functioning stormwater pond. I mentioned keeping a fertilizer-free zone around stormwater ponds. In Florida, all of our turf grasses are warm season grasses. This means that they grow optimally during warm or hot temperatures. During cooler weather, they go into dormancy or semi-dormancy. Dormancy or semi-dormancy is triggered by shorter day lengths and cooler nighttime temperatures. These shorter day lengths and cooler nighttime temperatures result in cooler soil temperatures, and the roots of turf grass will slough off between 40 and 60%. Because there's not as much root material there, it can't uptake the nutrients as efficiently as it does when it's warm weather and actively growing. This is why we recommend fertilizing only between, in Central Florida, about April 1st and at the latest November 15th. This is very challenging because many Florida residents think that their grass should be green, deep green, year-round. When we promote a lot of shoot growth during dormancy, when there isn't enough roots to support that growth, we can cause the turf grass to be stressed. Remember, root to shoot ratio. When turf grass is stressed, we can promote disease and pest issues. When we have disease and pest issues, it's a vicious cycle because now we have to use more pesticides. Turf grass really just wants to rest during the winter. Let it rest and let those roots become strong so that when it does warm up and it starts to green up more on its own, we can apply a little fertilizer and have a really healthy summer lawn. So what do we do for landscape problems? We assume that there's a pest or a disease problem, and we manage for a pest or a disease issue. Yikes, this is the wrong approach. In some cases, a pesticide may be the best or only alternative. Or is it a knee-jerk reaction due to social norms? The correct approach is to utilize integrated pest management. We want to identify, make sure we actually have a pest, and monitor that pest population. We want to consider cultural factors. Are we over-irrigating, over-fertilizing, pruning improperly? We want to consider utilizing physical or mechanical controls. Can I pull a couple of weeds instead of using a pesticide? Am I able to prune off a diseased portion of a shrub, dispose of it properly, and clean my pruning equipment? Then we need to consider biological controls. Remember, less than 1% of insects are harmful to plants. There's so many good bugs out there that we need to be aware of. Then, when you do use a pesticide, make sure that you're not using the same pesticide over and over again for the same problem. If it's not working, it may be because it's not the right pesticide, it's not the right problem, or there's a pest resistance issue. If you're going to utilize or make recommendations for pesticides, we should be concerned about pesticide fate in the environment. Pesticides can be adsorbed or adhere to soil particles and move with erosion and then be released into water bodies. They can be transferred on your clothing, your pets, and other animals. They can be degraded by microbes in sunlight, or they can be volatilized into a gas and get into the atmosphere. One of the biggest concerns about pesticide use is water quality issues. Pesticides can run off with surface water, so with rain and irrigation. They can also leach through the soil profile and get into our groundwater or aquifer. Remember that the greatest potential for pesticides entering the environment is immediately after application. So be sure that if you've made a recommendation or you're going to use a pesticide, that you've read the label completely and know how to use that pesticide properly. But in most cases, it's not even a pest issue. Or if it is a pest issue, it's due to some underlying problem, such as an improper cultural practice. So always investigate those types of things first before making recommendation to use a pesticide or thinking about using one. This photograph shows an alternative maintenance scenario. Taken right after a winter freeze, it doesn't look optimal. However, it has allowed the plants to reach mature size and provides a lot more habitat and biodiversity than the previous photograph. I hope you have enjoyed this presentation and have gained a little insight into the urban development process and the challenges involved in maintaining urban landscapes. Please feel free to contact me if you have any questions or concerns about this presentation.